Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to another Godot tutorial series. In this series, we're going to be making a simple space shooter game called Gravity Defiance. And I'm actually going to run the project here so you can see what it will look like when we get to the end of this project. Here we go. We've got a basic spaceship with some movement. We can fire some lasers. Got some enemies coming down at us that we can shoot. And as your score increases, you'll get some enemy variety. Start to get some new enemies. Got our score up there displayed. Got sound effects. Let's get to where we get the third enemy real quick. Okay, there's the third enemy. It will come down, bounce off the walls, fire a shot down at us, and then repeat that pattern. Okay, let's die here, and we've got a game over screen with a score and a high score. Our high score will be saved. If we were to close the game and run it again, then we would have, it would still remember that high score. Before we get started, I want to give a shout out to the two asset creators that we are using assets from. Right here, we've got Graphics Kid, who did the sprite work for these this retro space shoot 'em up. We'll be using modified versions of these assets. I'll provide a zip folder with those assets to you in this series. And then also we're going to be use Kenny's fonts. So Kenny.nl, he does a lot of free assets, and we'll be using his font for this project. One other quick thing I want to mention before we get started is that this series is going to be different from the other tutorial series that I've done in the past. And I'm going to basically it's going to use a combination of some video content and some written content, written tutorial content through provided scripts. The scripts will have comments documenting what those scripts do. And so there's going to be a mixture of written content and video content. This is something that I wanted to try, and you'll kind of get a better idea of how it's going to work just a little bit later in this video. So I don't want to go into too much detail, but just know that this is a bit of an experiment. So I'm looking for your feedback. You can let me know whether you like it more, whether you like the old way I did things more. Just I'm looking for some feedback on this new approach. Okay, let's get started. So I've opened up Godot. I'm using Godot 4.1.3 stable. I suspect that this will work on future versions of Godot 4, possibly even Godot 4.2. So that shouldn't matter too much. Let's create a new project. I'm going to browse into Godot 4 tutorials. We're going to call this project Galaxy Defiance. I can spell it, hopefully. And we'll create folder and create and edit this project. Okay, so we've got a new Godot window open here. We're going to create a new 2D scene, and we'll call the scene world. We'll save this scene, and we'll right click on it, and we'll set as main scene. That way, every time we run our game, it runs this scene right here. Now we need to adjust the project settings because our viewport size here, our window size is not correct. So we'll go to project settings. Now we'll need to turn on advanced settings. By default, Godot has basic settings on. We'll turn on advanced settings to display window. And here we're going to set our viewport width to 160, our viewport height to 240. And then we're going to send our width override to 640 and our height override to 960. And everything else should be, let's see, actually stretch mode, we need to set our stretch mode to canvas items. So what that will do is it will just take our small screen that we have here, and it will scale it up to that larger size that we passed in as the the window override. So it's going to stretch that small canvas up to that larger window. The other thing we need to do actually in the project settings is search for filter. And under textures, we want to make sure that our default texture filter is set to nearest. And that's because we are doing a pixel art game. So linear filtering will actually add a subtle blur to your pixel art. So we set it to nearest, and that will prevent any blurring on our nice crisp pixels. So now I'm going to open up this folder here, which is called the Gravity Defiance Resources. And I'm going to select all of these resources right here and drag and drop them into the Godot project. Now we have our world scene, and we have some different folders here with some resources. Assets are essentially just the sprites that we'll be using. And then we have effects, which is just a simple white flash shader. If you're interested in shaders, I have a recent video that talks about how to make a simple shader like this. And then we've got the font from Kenny, and we've got some sound effects. These are sound effects that I made. And then we have some components, and we're going to get more into what these component scripts are in just a minute here. Our project setup is done. Now it's time for us to create our player ship. So let's create a new folder. I'm going to call this folder player_ship. And I'm going to create a new scene by clicking that plus button. We'll do a 2D scene, and we'll call this player, or we'll just call this ship. And we'll save this scene inside of player ship, like that. Now we need to build our ship scene from some of Godot's built-in nodes. Let's zoom in here with the scroll button. We can add a new animated sprite 2D to this ship. This node right here will allow us to draw a sprite and animate it. So we'll click on it. We'll click on sprite frames here. We can select new sprite frames. Actually, real quick before we move farther into it, I might make a note of this in the comments below, but this is a tutorial for beginners. If you're brand new to Godot, then you might want to watch some of my other tutorials first, my platformer series, for example. But overall, this tutorial series is aimed at beginners. Now that we've got our sprite frames here, we'll create a new animation. Here, we'll call this center. And we'll grab our frames here, come into assets. So you just press this little button here, come into assets, click on ship. You can see we have 3 frames in this. So vertically, we want to set this to 1, and horizontally, we want to set it to 3. We can select all 3 of those. Now we've got banking left, center, and banking right. I'm going to create 2 more animations. Bank left. Bank might not be the right term. I don't know what is, but I just used it. So then we'll take this one here, and we can copy it with this button, copy. Come to bank left, and then paste it with this button. Come back to center, and now we can delete that because we already have that frame in our bank left. Now we'll come to center. We can copy it, or not center, copy the bank right. Come in here, paste it, come back to center, and delete it. Now we have these different animations depending on which way our ship is moving. For now, let's just click this autoplay button for center. So we have a sprite set up for our ship. Now we need to be able to put the ship inside of our world scene. So we'll come back to world, come down to here, and we'll drag and drop the ship into our world scene. We can turn on snapping here, and I'm going to recommend that we place the ship at, I'm looking at my reference project. Let's see, position 8216. So click on the ship scene inside of world, come to transform, and we'll do 80 and 216. There we go. That just kind of places it at the bottom of the scene. Now, if we run our game, we can see our ship down there at the bottom of the screen with nice crisp pixels. This is a good start. We'll come back to our ship, and now is where we get into what I feel is the interesting part of this series, of this tutorial series, and what makes it different from other tutorial series. So we're going to be building some components for our ship. These components are essentially just nodes that perform some job. So if you look at the sprite, the animated sprite node here, it is a component. It's a node that performs some job, and it doesn't really need to know a lot about the nodes around it in order to perform that job. It can just kind of do that. It can display a sprite, show an animation, right? And so in this series, we're going to be making some of our own custom components. And I've already created some custom components that we'll be using. And each of these components is documented in some way. So if we look at our stats component here, you can see I have documented this component with some notes. So at any point when we're using one of these components, you can go in and look at the notes to see how this script works. But we're also going to be creating a few components here. So let's click back on our ship. And the first component we're going to create, so right click on components, do create new script here. We're going to create a move component like this. Okay, so I created this new script called move component. We can open it up. And this move component is going to be pretty simple. At the top, we'll give it a class name. And this will be move component. This. And then we'll do something in this component. The job of this component is to move an actor. So in order to get that actor, we need to pass it in. So we'll use an export variable for this. So export var actor. And this actor has to be at least a node 2D. So it has to be node 2D. Otherwise, it won't have a position that we can alter. Okay, so when we export this script here, what it does is it allows us to edit this variable in the inspector. And I'll show you what that means in just a second. But first, we need to now move this actor. So inside of our process function, so the process function happens every frame, we can say actor.translate. So that moves the translate function moves the actor by a certain offset. Now the offset that we're going to do is going to be a velocity times delta. But we don't have our velocity yet, so we need to export that as well. We've exported actor. Now let's export our velocity. And velocity is going to be a vector too. That's just an x and y value combined with each other. So we can now say velocity times delta. So every frame, we're going to move our actor by this velocity multiplied by delta. And delta is the time that the last frame took. That just makes sure that our movement is smooth, is smooth independent of the game, how fast the game is running. So if you have like a lag spike, it will help your character to be smooth even during that lag spike and move at a consistent rate during that. So we have now created our very first component. Cool, huh? Okay, so when you create a component using class name, you're essentially extending Godot. You're taking the Godot game engine and you're adding a new node to it. So we can come to our ship and we can click the plus button, and now in here we can search move component, and we have our very own custom node here inside of Godot. And this is going to be the basis of this series, which is extending Godot with custom nodes in order to create our own version of the Godot engine that is specific to the game we are working on. So this move component might not work in a platformer because it acts on a node 2D. For a platformer, you would need to do a character body 2D. But it's still useful because we'll be able to reuse this move component node multiple times within this game. So maybe it won't work for every game out there, but within this game it will work, and it might actually work in other games too. So we're able to share code, not have to rewrite it. Let's add our move component to our ship. And we need to assign the actor. So remember when we exported actor and I told you that we would be able to set that variable inside of the editor? When we click on move component here, we can see our velocity and we can see our actor, and that's because we've exported these values. So that's a crucial part of creating these components. So we'll assign our ship. We just clicked on here and then selected the ship. And then we can set our velocity to something. So for now, let's set our velocity to -50, okay, in the Y. Now if we come back into our game and run the game, you can see our ship actually moves up, right? And that's just amazing to me. We can reuse this move component in any other place that we want and have the benefits of being able to move something by setting its velocity. Okay, so that's step one. Let's set the velocity back down to 0 because we want to be able to control this velocity, right? So step 2 is to create a new component here. So we're going to right click, do create script. We'll call this component move input component. This, we'll create it. And when we come into move input component, we'll give it a class name, move input component, this, and it's not going to need either of these functions. So what does our move input component do? What's its job? That's an important question. Our move component, its job is to move an actor using a velocity. The move input component, its job is to get some input from the user and then set the velocity on a move component, okay, based on that input that we got. So we can do this by saying export var move component. And this move component, in the same way that we needed our actor for the move component to be of type node2D, this move component needs to be of type move component. Now again, because we used that class name, we can now type this variable to make it so that in the editor, the only node we can click on when we try to set this variable will be nodes that are move components. And I'll show you what that looks like when we get there. Now we need to call our input function, input. So this is just the input event in Godot. We could do this in a process function as well, but I'm doing it inside of input. And we'll say var input axis equals input dot get axis. And then we want to do UI left and UI right. Okay, so input.getAxis, what this does is it returns a value between -1 and 1 based on whether or not these input actions are being pressed. So if we're pressing only UI left and not right, then we'll get -1. If we're pressing only right and not left, we'll get +1. If we're pressing both of them or neither of them, we'll get 0. And that's how it works. On like an analog stick or like a game controller of some sort, you would get a value between -1 and 1, but it might be different. It might be like -0.25 or something if you're only holding to the left a little bit. So keep that in mind. Once we have that, we can actually set our move component's velocity. Move component dot velocity. Now, Godot can autocomplete this because we've typed it up here. So it knows that this move component variable is of type move component, so it can auto fill in velocity here. And then we can say equals vector to input axis for the x position times 100 or times 50 for now. We'll change this in a second. And then for the y, we'll do 0. So this input component can only move left and right. And again, we're extending the code for our specific game. So this game, the ship only needs to move left and right. Now we can come back to our ship. We can add our move input component to our ship. So we've added that node. And now watch, when we click on the move component here to assign it, you can see we can't select any of these other nodes. And that's because they're not of type move component. This helps prevent errors, right? It helps to prevent you from accidentally clicking on the wrong node. We'll select our move component here. And now, this is kind of an important thing to understand. This input component is dependent. It has a dependency, and its dependency is this move component. If it doesn't have access to the move component, then it can't function properly. And you'll get an error if you don't set this in the editor. If you don't set the move component, you'll get an error. And I think it's actually good to show that. So we're going to run the game. We haven't set it, and here we get an error. It says invalid set velocity on base nil. So it's saying that we can't set the velocity variable on nil, which just means an object that doesn't exist. This move component doesn't exist. You never set it, so it's at nil. So if you get like an invalid set blank on base nil, then it's likely that one of your components hasn't been set up in the editor. So even if your code is completely perfect, you've written all your code perfectly, if you don't set up the component in the editor, you could get an error like this. Okay. So now we can move our ship from side to side. Cool, right? So we're starting to see how these two components can work together. Now the third element here is going to be move stats. And calling it a component is maybe a stretch, but it is just, it's a way that we can decouple this speed right here inside of our move input component. So we can come down into our components, we can right click, we can do create new, do a new script. Now this is going to be a slight exception. So we're going to call this move underscore stats, but it's not going to inherit from node. In Godot, you have nodes that are one of the building blocks of your game. You also have resources that are a different type of building block for your game. The resources aren't generally created inside of the scene here. They're created inside of your file system. And an example is a script. A script is a type of resource. A sprite, like a texture, inside of our assets here. Our assets, all the sprites are all resources. We're going to create our own resource. And this resource, so we need to inherit from resource here in our script. So now we have move stats. It extends resources. We can give it a class name still, and we'll give it move stats as the class name. But we're extending resource so we can instance this in the editor. And we're going to export speed. And by default, we'll set the speed equal to 100, and it'll be an integer value. It could be a float. Either way, it doesn't matter that much here. So now that we've created this move stats resource, we can actually come down into our player ship folder here. We can right click and do create new resource. And here we can we can find move stats. See that? Because we extended resource, now we have move stats in our resource list here. And we'll call this ship move stats. Great, it's a .tres file. And we can set the move stats to whatever we want. So let's say we set it to 50, okay? Now come back into your move input component, and we're going to give our move input component another, we're going to give it another, whatever this was called. I'll remember here in just a second. Let's start though. Export var move stats. Move stats. Okay, so we're extending move stats. Now if we come to our move input component, you can see there's this empty spot here where we have move stats. We can drag our ship move stats and drop it right here. Now, instead of multiplying our input axis by 50, we can multiply it by move stats dot speed, which is set to 50. But this just decouples the speed from this script and allows us to, we could reuse this move input this move input component for multiple different ship characters. Say you had 5 different ships in your game. They could all use the move input component, but have different stats associated with their movement speed. Okay. Now we can move our ship. It's still moving at a speed of 50, but I do want to actually set this back to 100. And now you can see we're moving at a speed of 100. Our ship can move faster. And that is going to be the stopping point for this first video. It's going to be a little bit of a longer video, but we got the basics for it in. We've created 2 components here. Actually, there's going to be one more thing we're going to do. We're going to use one of the existing components that I have. So we're going to come here. We're going to attach a border. No, it's going to be a position clamp component right here. So we'll add this position clamp component to our ship. And the job of this component is just to clamp the ship to the view. So you can see that, well, if we assign an actor on this component, we'll assign the ship, okay? And then we'll give it a margin of 8. That's fine. The margin is just how much edge you want on the screen when you're clamping. Now if we run the game, using that component, our ship can no longer go outside the screen. So we're able to use one of the custom components that I made. And you can open up this component and look at the script inside of it to see how it works. It essentially just gets the width of the screen, uses a margin, and then clamps the X position of the actor between that left border and that right border. It's documented here, you could read through it. And there we go. That's how this series is going to play out. I also wrote a Substack article on this same idea of composing a game using composition over inheritance through components like this. I'll link to that Substack article in the description. I'll also link to the GitHub page for this project so you can download it and see kind of how it's set up if you're interested in that. And I hope you enjoyed this video. I hope you learned a lot from it. And I'm also doing a sale on my 1-bit Godot course, the 1-bit Godot course that I redid for Godot 4. I'm doing a fall sale that is pricing the course quite low. That ends at the end of this month. So if you're interested, go check that out. Thanks again for watching the video, and I will see you all in the next one.